And welcome back. As we go ahead and continue to look at programming with Python, previously we had looked at classes, and now let's go ahead and extend that so we can look at how we can use inheritance. So as we already mentioned, Python has inheritance. And because it has inheritance, that means that we are going to be able to use some class structures that we already are kind of familiar with. Recall that inheritance allows us to define a class that inherits all the methods and properties from another class. A parent class is the class being inherited from, which is also known as the base class or the superclass as we sometimes have referred to it in the past. And a child class is the class that inherits from another class, also known as a derived class or sometimes a subclass. So let's start first with our base classes or our parent class. Let's assume we have a class called person. And in here, person just is a very basic thing. We are passing in a first name and a last name parameter, and we're defining those as such, and we have a method that allows us to print those out. So nothing too complex here. When we look at the derived class or the child class here, if we want to create that class and is going to inherit functionality from another class, we're going to send that base class, so person, as a parameter when creating the derived class. So class student, parentheses, person. And then, of course, you see underneath I have this keyword pass. And what does that keyword pass mean? Well, the pass keyword just means we don't want any other properties or methods to the class. And a lot of times this is not necessarily the case because we are going to want to give it its own properties because it's going to have its own parameters or values that we're going to want to include. Now, the student class has the same properties and methods currently as the person class because again, we just use that pass keyword. We could then use the student class to create an object and execute the print name method. So I could say x equals student Mike Olson, and I could say x.printName, and of course it would behave just as if it was part of the person class, only it's a student object. However, a lot of times, like I said, we want to give those derived classes their own properties, as we have done in the past, because a lot of times we want to be more specific in what those derived classes are doing. So we're going to need our own init function to that derived class. So with our derived class, it's of course inheriting the properties and methods from the base class. But if we want to define our own properties for that defined class, well, we're going to need, again, that init function instead of just the pass keyword. So in here, you can see we've redefined it as class student person. That's the same. But underneath that, instead of saying pass, we say def init, and we're having a self first name, last name, and then we can add our properties. Now, one of the things you'll notice is that init is exactly the same as what we had in our base class. And this means our inheritance is going to have the ability to start overriding some of those base class properties. When you add the init function, as we saw, the derived class will no longer inherit the base class's init function, because it's saying instead of using this set of parameters, I want you to use this new set of parameters. So the derived class init function overrides the inheritance of the base class's init function because remember, they looked exactly the same, and because they're exactly the same, it's replacing what was there. If we wanted to keep the inheritance of the base class init function, we could add a call to the base class init function. So we could say class student person, def underscore init underscore self first name last name, and underneath that in the definition, we could say person.init self first name last name. So that's one way for us to go ahead and preserve some of those parameters that we might have had otherwise thrown out. Conversely, another way to approach this is using the super function, which is something, of course, we're very familiar with when we use our super calls in creating our own derived classes previously. Python has a super function that will make the derived class inherit all the methods and properties from its parent, which again is very useful and is probably an easier way for us to handle. And it's also a way we're more familiar with coming from our experience with things like Java. So here we can say class student person, def init self first name last name, and then you can say we say super.init first name last name. You'll notice though there is of course still a call inside of that definition. And when we use the super function, you do not have to use the name of the parent element. Instead, it's automatically going to inherit all the methods and properties from its parent. And this can be really helpful when, for example, we start getting into, a second generation derived class. So you have a parent function, a parent class, and then we're deriving a class, and then we're deriving a class from that derived class. So super calls can get very handy. So we're not having to have this long chain of classes that we're trying to manage. Now, what about adding properties to that derived class? Because again, remember, one of the things that a lot of times we do with those derived classes is we make them much more specific. We're looking for specific roles and purposes. So we can very easily add additional properties to any derived class. So for example, if we looked at our student class and we say we want to add graduation year to that class, I can just come in here and in that initialization, I can say self.graduation year equals 2019, and that would add that property to it. Or the other way to do this is by creating an additional parameter, which sometimes might be better because then if you need that parameter to exist, then you can have it exist throughout the class. So here we are initializing it with self, first name, last name, year, and we're saying self.graduation year equal to year. And so then of course we were to print that out, we would then have it say Mike Olson 2019. It is another way of approaching it. Now, what about adding methods to our class? Well, we can easily add additional methods to any derived class, similar as we can do with additional parameters. So, for example, here we have a new method called welcome that we're defining that's simply just going to print out those values there for us. Now, if you add a method in a derived class with the same name as a function in the parent class, the inheritance of the base class method will be overridden. So keep that in mind if you start having methods that have the same name. Remember, it's always going to operate, if it's in a derived class, it's going to use the derived version rather than the base class version. And here we can go ahead and take a look at our example. So we have a class called animal, which initializes with the parameters name and species, and then it can print that out. And then we created a derived class called pet, which of course you can see it's also taking a name and species, but we've added another parameter called age. And then, of course, we have a new method down here called welcome, which, of course, is going to print that information out. And down here, we, of course, have our actual code that is going to create that for us. In fact, let's just go ahead and actually put this code inside of a main here, just so that way it's kind of nice and cleaned up here for us, so that way we don't have to worry about that being in a different level. We can have it nice and defined. And then let's just call that main. There we go. So now if we go ahead and give this a run here, we get this is Fluffy, who is a cat who is 5 years old, and because it's calling this welcome right here, it's a dot welcome. Now what if I call this print info? Let's change welcome to print info here, and just see, does that change anything for us? If I rerun it, you notice we get the exact same output because again, we're using the print info that is not defined here in the base class, but we're using print info which is defined here in the derived class. Now I'm just going to back that up just for a minute, and let's just go ahead and change this right here to print info, because now print info is of course a method that's belonging to the animal class. If I give that a run, we get Fluffy Cat, because again it's using now this method. And that is important to keep in mind because we have not defined print info here. However, because it is inherited from animal, we still have access to it. And that's very important to keep in mind. One of those beautiful things about classes and inheritance is if I needed to create methods that belong for animal and then I create a derived version, I don't have to redefine those methods, because as long as I'm not trying to change how they function, I can keep using them here in their original form, and you can see they work just fine.